overall, I also want to thank Elaine Bertolini as well as Zach Pop for assisting me today from the CAFÉ team. For those that don't know me, I'm Kevin Lane. I'm an assistant professor in the Department of Environmental Health, and I'm also our chief data officer for our Center for Climate Health at BU. And on CAFÉ, I co-lead the data management function core with Danielle Braun at the Harvard School of Public Health. And when it comes to GIS, it's actually something I'm very passionate about. I've been working in GIS for over 20 years now and been teaching it for 12 years in multiple different formats, including softwares like Esri ArcGIS, ArcPro, Quantum GIS, QGIS for short, that we're going to be going through today, which is open source, and then R as well. And today we're really going to be focusing on a 101, which is really the basic of GIS in an open source user-friendly software like QGIS. A lot of the things I'm going to cover today are transferable to other softwares like Geoda or also ArcPro as well. But since I also have training materials on those, we'll be posting those periodically to the resource as well. Additionally, when it comes to GIS, don't worry if you've never done this before. As this is a GIS 101, I'm actually making the assumption that a vast number of people might have had some level of interaction with this, but maybe it's a refresher and need to go back. So in terms of the agenda, what we're going to cover here in the next 2 hours is really going to be focusing on just a brief introduction to what GIS, with really trying to just emphasize some of the key points around the differentiation between map making and spatial analysis, which we are producing different code sets and open source approaches, especially in R, to do spatial analysis, but also can, if it's of interest to the community of practice, be able to provide more of those hands-on training in QGIS, Esri, and so on. Also, we'll cover briefly the importance of spatial scale. Then what we'll do is we'll turn to actually hands-on training, where we're just going to be covering the basics of working with the software, how you turn it on, how you add a layer in, how do you conduct some basic queries, searches, sorting of data, and then we'll do some selection, subsetting of data, aggregations, and so on, and then make a new shapefile and end with creating a map at different spatial scales as well. There will be a Q&A at the end as well. Some of that time we might lose if there's requests for clarifying questions, which leads me to how you can interact as well. We have the chat being monitored by Zach here today, and Zach will interrupt me if there's questions on clarifications that are needed and or anything that you would like to maybe have me repeat a step on as well. We will be making all of this available, as I said at the beginning, so if you miss something here or a step is passed and you want to proceed along, then you'll have the opportunity to go back and get the video. And since the data has been made publicly available, you can always download that. And Zach is putting the link into the chat periodically so that people can go and get the data if you'd like to live follow along today as well. So to begin with, we're going to start off with just a very brief lecture, I think hopefully even less than 15 minutes overall. And I'm going to start off with the super basics. What is GIS? And it's really a geographic information system. So really what we're talking about here is adding the where to existing data. For instance, you can have electronic health record information that could be at an address level or a zip code. And that zip code and address would be the where that allows you to put data into real world latitude and longitude, so you can put them into a map based upon a coordinate reference system that you want to use for your data. Spatial statistics is a lot of times some different things, and depend upon who you talk to in the GIS world versus on the analytical field, there can be very large differences overall in some of those understandings. And spatial statistics really is incorporation of things like spatial autocorrelation. It's not something we're going to be covering here today, but it is an area of specialization. If there's interest, we could always add in some more trainings or code sets to work with that. When it comes to GIS, it's also important to have the idea that, like, there's not just where things are, but it's linkages of a database, especially what we refer to as geodatabases or also shapefiles, where we refer to those as vector data sets, as opposed to a raster data set, which would be an image picture. Today, we're only going to focus entirely on working with vector data sets. Rasters will come later, but we also have some on our CAFÉ GitHub. How do you work with raster data processing, especially things like satellite data? And when it comes to GIS, what we're going to be doing, and really the essence and value of it, is being able to overlay maps, like you can see on the right-hand side here, where you can store and manipulate different data, conduct spatial queries, and really this layer cake of information becomes highly valuable, especially on data sets that might not be able to be merged through unique ID or codes, which is something more familiarly done in different softwares, Stata, SAS, or R itself. When you want to merge two existing files, you need to have a existing code that would allow you to do that. In this world, with GIS, you can use the latitude and longitude to conduct those, what we refer to as spatial joining of data itself, where you can take information from topographic, zoning, you could look at health information, land cover, and you can merge them all together based upon their actual latitude and longitude systems. Now, an important distinction here that I want to also just raise is related to the map making element itself versus formal analysis and spatial analysis. And sometimes this is referred to as spatial analysis, but researchers or other people in GIS work, they're really talking about spatial data manipulation, such as, maybe merging different data or conducting a spatial smooth on an information, which is something different than formal statistical analysis itself. And GIS specifically in and of itself, when you're creating a map, is not a statistical or scientific inference process. It's really something to help supplement that as well. And maps in their most basic fundamental approach are not statistical inference. As much as many maps as I made, especially working with my community partners, there's something about place when you see it on a map where you live, work, and play, and then overlaying that information with things like air pollution or extreme temperature values and being able to say, see, I have this association because it's tangent, it's something that is visceral, as opposed to maybe seeing a data set as a table form or even a figure itself. The big difference is those tables or figures might be representative of formal statistical tests, ANOVAs, regressions that could be done. So you can see associations there that are actually based upon statistical inference. GIS on its own, when we're looking at one variable, is sort of just analogous with a histogram, or even if we do an overlay, it's really scatter plots or 2x2 tables, with the location also being one of the axes, while you're showing what the distribution is of something like air pollution or health outcome that you're interested in overall. But unless you actually do a formal statistical analysis, something like a geographically weighted regression and show it, or you do a Kriegan approach or something else, or you're using a map to illustrate where your regression models would have statistical significance distributed across your study for that relationship, the best part of a map, especially if you're considering utilization of maps for publications, I really find is maps are really fantastic if you want to display your study area and get a general understanding of independent parameters, or maybe two parameters at one point in time, their distribution spatially across your study area of interest. Really, where maps also become powerful is when they're really tied also to existing figures in tables that are more formal regressions as well. Because statistics just on their own are going to go well beyond just the histograms or scatter plots we would use when we're formally looking at 2x2 or 1x1 variables overall, just like in GIS with a map. We need to be able to go beyond that as well. And when it comes to spatial analysis, there's lots of different sophistication. Today, we're really going to focus on spatial data description. How do you look at the data itself? How do you make maps? That would be more general, one variable at a time, with, depending upon how fast we get through this, maybe a little bit dabbling or talking about exploratory spatial data analysis. More formally, there's other trainings I have that we'll try to post that are related to spatial stats, like proximity analysis and cluster analysis, as well as spatial Kriegan. I do also want to take a moment to just talk about spatial scale. And while today for this session, we're going to focus on some US-based data sets, in future trainings also we can integrate in global data sets as I do a lot of this work, not just here, but globally as well with different groups. Specifically, we can look at the census for the United States as a nice way to understand and visualize the importance of spatially diverse information. So what we typically have in the US Census for our spatial data sets is state level information. And within every state, you'll have counties, within counties, county subdivisions, and within county subdivisions, we can get at what's referred to as tract level information, which is typically populations within a county that are broken up based upon different demographic characteristics and range between approximately around 3,000 people and 8,000 people within that given area. It could be considered a neighborhood level, with sometimes it being a smaller or larger number, depending upon if you're in a highly urban dense population area versus a rural community as well, and it's more spread out. Within tracks as well, we can go a little bit lower and get at block groups and even block level information. Although when we get down to blocks, what we're typically looking at is a more limited data set overall with potentially greater error bars due to differential privacy. Now, the importance of having the data that can be very flexible is that you can have multi-level analytical approaches. Maybe you're interested in looking at a national-based question, so you might want to look at, county level information or district level information or town level across the United States. Or maybe you want to look at prioritization of resource allocation within a particular city, village, or district, and want to be able to have that hyper localized point or aggregated sort of population information at a lower level as well. And really, if we want to improve exposure assessment, we could think of this a couple different ways. There's been a number of different publications that have looked at, temperature at county level information on a national scale versus maybe looking at urban heat island metrics and their impact, or they're being reduced based upon different urban plan strategies like improving greenness or albedo surface painting. That's something where we might want to have a hyper localized analysis at a census tract or smaller to be able to identify where we should affect those changes. So having your data at different spatial scales really matters because it can help you better understand environmental and social determinant of health that are really complex and depend upon the scale of what you're analyzing, and then maybe want to look at for a policy or an actual intervention will require commensurate level maps to help inform those decisions as well. So again, having flexible data on social or environmental factors at different scales will allow you that flexibility overall. But sometimes you're limited in what you can do as well, and you want to think about aggregating or disaggregating your data. These are all just things you can keep in the back of your mind as you're working in GIS and as we start to go through the training today as well, because we'll work with different data sets at a small local level, but you'll see when you're making maps, even looking at national level information across the entire country, sometimes you want to aggregate your data, and I'll show you how to go about doing those steps as well. Just a couple other points I'd like to reflect on in terms of what we're being working on today, and also served as an impetus years ago for me getting into this field in terms of wanting to share data more publicly and create trainings and modules that would be affection for publicly available data, is around a project referred to as CRUSH, which was the Center for Research in Environmental Social Stresses in Housing. And really, when you're working with GIS, you want to, again, especially when it comes to health information, won't be publicly available. But when you're thinking about things that could be modifiable, aspects of different data, everything you're seeing here at least has been able to be obtained for the entire United States. And in many countries, we're able to get a lot of these different data sets as well, especially through open source platforms such as OpenStreetMap as well for location-based data. And having these data sets, from administrative or satellites will allow us to do a lot of different climate health related research. And even today, the training data set that we're going to use, everything is publicly available. I've already done the work ahead of time to merge these different data sets with a census shapefile geography. So we have some data that we've merged from the Atmospheric Composition Analysis Group, the ACAG group, led by Randall Martin. and they provide publicly available global PM 2.5 estimates that are also used by the Global Burn Disease. There's other air pollution models specific to the United States and other areas on CDAC, for instance, that also can be used, but I want to show what can be done utilizing a globally based data set just being applied in the United States itself. So our PM 2.5 air pollution data that's in the data set comes from there. And then what we've done is I've merged it with the American Community Survey census data. We also, for temperature, we've utilized the PRISM data set from Oregon State, although this mechanism of how I joined everything, we actually have some training for on our GitHub, and also could be used in terms of data processing for other things such as DayMet as well. Also have joined it with some toxic release inventory site data from the Environmental Protection Agency. And then for the health outcome information, we downloaded and joined the CDC Places data, which allows for major cities across the United States to have prevalence estimates on a variety of different health outcomes. One we'll look at today is coronary heart disease at a census tract level as estimates of prevalence per 100,000 persons. So if you are looking for the data, one of the key things is you can, at any point in time, I want to also share our website here, where you can go to by just Googling Climate Health Cafe. You can find this here. And then under the resources, you can find our data resources. Also, we have educational resources, which is where we'll also have this link. And we're going to be updating our website as well, but you can also see other educational materials in here and other ones that have already started to be done and posted. In terms of the data, if you wanted to find this by not going through the link, you can always come to our data resources and then scroll down a little bit. The GitHub is where we're actually providing a lot of different code and training tutorials on actual code development. A lot of this is in R. And then the Dataverse is one of the areas where we've created a repository for researchers to place different existing data sets. And what we've done is we've placed the training data sets up here as well. So you have the US Census QGIS training data that you can download here just by clicking on it. And under the Access data set, you can just download and unzip the data. And if you are going to be following along today, you do want to make sure that you unzip the information before you start as well. So I've placed everything into my QGIS 101 here. Yep. You can see here, so the shapefile that you should have unzipped and moved over will have all these different components here. And that's one of the reasons why we're working with a shapefile today and not a geodatabase. Otherwise, this would be a smaller, more specific, but working with a shapefile, because that's also a very commonly used data format in spatial analysis and work. And I don't want to make any presumptions about people's experiences with different softwares. So I also want to just show, like, if we want to unzip the data, just make sure that you create a folder for it somewhere and move all of these pieces. If you only were to move one of them, such as the .shp, the file wouldn't actually work. You need all these components. The DBF is the actual data for the database. The shape is the actual shapefile and the vectors. A lot of these are connector pieces that allow the DBF to be searchable when you select on the SPH file or the DBF within the GIS software. And additionally for projection, so that we know what coordinate reference system the data is stored in as well. And now what we're going to do is we're going to turn over to the hands-on training portion for approximately the next 90 minutes here. And if there's any questions, you want clarifications, please feel free to pop it into the chat and Zach will let me know. So first I'm going to begin is I'm working on a PC. So I do want to be clear that one of the benefits of QGIS is that it can be available for both a Mac as well as a PC-based operating systems. So it can easily be worked there. I work a lot for years in Arc Pro, and in that case, you have to run boot camp or with a Windows operating system on a Mac to be able to process. Everything we're going to be doing for Q should be similar, but sometimes it might just look slightly different, some of the boxes that I'm opening. So if you see something that I'm looking at and it just looks a little bit different, That's usually due to the difference between Macs as well as with PCs. So I just want to clarify that. So if it's not perfectly matching, that's usually the difference, and not that you have a bug or some different software that you're working. To launch this, I'm just going to go into my softwares and then just launch the QGIS desktop. Now I'm using the most recent version right now. And Zach, I'll just say, like, if there's any questions, also feel free to interrupt me with them as well. Sometimes it can take a moment for the software to open. Great. And I'll take a moment here because other people, I understand, when you're doing the steps, there's typically a lag between seeing and looking at the screen and then switching screens so that you can actually follow along. So I will be pausing periodically, and it's to make sure that people have time that are following along live with us today have that opportunity to do so as well. If this is your very first time opening the software, you won't have sort of the same setup that I do, but it'll look pretty similar. So on the left-hand side, what you're going to see is you'll have all the ribbons at the top that you normally would when you're working with different softwares in sort of a window-based environment. On the left-hand side, you're going to see the layers panel, and this processing toolbox may or may not be open on the right-hand side. In the middle, this is sort of like new information that the software and the users are going to be sharing with you. I'm just going to close this window at the top just because it's a loading issue. And then if you have recent projects, this will be open or this will be empty. To begin with, I'm just going to clear all this information by just starting a new project. And that's as simple as coming up into this ribbon, and right where it has this little paper, it says new project. And just like anything with lots of softwares, if I were to click on this top ribbon up here and be able to open up one of the tabs, you can also see I can find new here as well. So a lot of these are just the shorthand keys, and I'll orient you to what is going on with each one of those. The first thing I want to do, though, to help make this software a little bit more intuitive is let's start off by just adding that shapefile in. That way we can begin to learn how to navigate in the software itself. To do that, in the very top, I click on this layer tab here. Then I can come down to add layer, add vector layer, and left click there to open up that window. I'm just going to pause here as well. And you can see there's a variety of different data sets that we can add for all. Excellent. And it opens up the new window. It's already on the vector. To do this and add the shapefile, I'm going to click on the ellipses here, or the 3 periods at the end where it's browse. And I'm going to navigate to where I have my data. So I just create a folder on my desktop and just called it QGIS 101. Wherever you've saved the shapefile, you can go ahead and do that. I'm just going to change this view to be detailed so it's a little easier to see. What we can do then is right below this little bar here, you can see all files. I'm just going to click here and change it to Esri shapefiles. That way we can see which one we want to add in. So again, all I did was just click on the little drop-down box and change it to say Esri shapefiles so that it knows the format. Then I'm just going to highlight it by left clicking and then click open. In order to actually add it to the data in the bottom right, I need to click this add button once it's loaded in. Then I can close my window and I can see the data set here. Now, what we can do is we can learn about some of the navigating tools. It will default typically to this pan button, which is the hand. So what we can do is click and grab, and you can move things around. If I want to zoom in, the magnifying glass is what we use to zoom in or zoom out. I'm going to go ahead and click the little plus, and if I wanted to click the plus magnifying, and I just left click anywhere on the map, it starts to zoom me in. If I want to fly in, I can always do a square, and it'll start to zoom me in smaller and smaller. If I make a mistake and zoom too far in, I can either use the minus magnifying glass up here, and begin to click to get myself out. Or if I want to reset right back to the original frame so we can see the full extent of the shapefiles that are contained within the layers, I can click this magnifying glass with the 3 arrows that says zoom full. And it'll zoom me out to the full data. I'm going to go ahead and zoom in just on the conterminous United States here. So I'm going to click and drag and draw a box using the plus magnifying glass. So I can move around, as you can see, very easily. Now, not just seeing the United States in its census tracts, we can also see data contained within them. By right-clicking on this tracts places, EH in the layer, so I just right-click over here, I get a whole bunch of other options. I can zoom in, I can turn labels on, and if I keep going down, I can find this open attribute table. If I left-click here, it allows me now to be able to see the data that's contained in that .dbf file that we saw in our folder. I can use the bar to scroll to the right and see some of the data sets that were added, such as the population, the area. The outcome information comes next from CDC places. So these are prevalence values per 100,000 estimates in census tracts in major cities. So it's not going to be in all the tracts themselves. So this would be for really looking at individual local level analyses. I can see the different mental health, obesity, stroke. If I keep going to the right, I can find max temperature, which has been merged from its raster-based format, as well as the PM 2.5 data in that format, to be able to have annual average PM 2.5. And this is the summertime maximum temperature average. So it's actually it's a summertime average value that we've taken for each one of these census tracts. And then also the number of TRI sites within each of the census tracts themselves as well. So these are the variables that we have within our data set. Working with this, if I scroll to the right so I can find our PM 2.5 data, I could see, okay, if I want to sort this, I can just, on the header for where it says PM2.5, if I left click, it's going to automatically sort this ascendant. If I click again, it's going to start a descendant as well. And many times, just like in different softwares, we'll have specific code to identify when we didn't have information for that area. So in this case, I've left in 9999 as being a parameter. So if we want to make a nationwide map of, for instance, PM 2.5 across the US, we first want to look at our data and then filter out areas that would have information that was missing. I'm going to close this attribute table. And the way that we filter data is that I can right-click on the tracked places and come down to this filter window. Pause here. And then I'm going to click. And it's going to open up a window that allows us to build a very short function using some of the operations. It looks very similar sometimes to me for like SPSS or something like that in terms of if you're more familiar with statistical softwares. And what I can do is I can build a filter where I scroll down on the left-hand top side here and find my PM 2.5 field. So this is particular matter 2.5. One of the key things is we typically don't like to have periods in some of the header names because sometimes periods can mess up some of the functions that are being run in especially older Python code and especially some of the old ArcPy code functions, which is what all this software is formally running on as well. So if I double click on PM 2.5, it puts it into my expression builder. Then I can click on the operator equal and just type in, if I wanted to, 999s to find those. But what we actually want is to filter everything below 999. So I'm going to put in a less than sign here and type 9999. Just so that we can filter out everything that is missing. I'm just moving the box because I also have some stuff in the way on the bottom, such as closed captions, so I can see everything. So there we go. Okay. Great. So now if I go back in, you can see now we also have this little filter on the right-hand side to identify that we actually have applied this. I can right-click on our tracks places again and come down to Open Attribute Table. So again, I'm right-clicking on everything to interact in the layer. And then coming down to Open Attribute Table. Now, if I scroll to the right and I sort my PM 2.5, sort again, so it's descending, I can now see that I only have census tracts that contain an actual value. So I'll close this attribute table. Now let's go into the properties. Now we have a data set, unique individual information. Oh, I'm seeing the chat pop up a little bit crazy. I just want to check that to make sure. Oh, it's related to downloading the data. Fantastic. Looks like some people are having some difficulty with getting the software downloaded. That's okay. I'm going to continue on. And again, this will all be put online so you can check it out. So if you want to manipulate the actual colors, or what we refer to as symbology in a map, what we can do is right-click on the tracks places EH again. So again, everything you want to do to interact with layers is always going to be a right-click in this layer panel over here. And then I'm going to scroll past the Open Attribute Table, come all the way down to where we see our Properties window here.
Hi, Kevin.
Yes.
There's just a quick question in the chat about why missing values are being renamed to 999 and not being renamed to something like text, like a hyphen.
Oh, fantastic question. Thank you for interrupting that. Let me go back. That's a great little addition. So in other softwares, yeah, you might be able to mix text and numeric fields. When it comes to GIS shapefiles, geodatabases, they do not like mixing of text with this. It would automatically default to just being a text-based field instead of an integer-based. So a lot of times that's why we'll create a fictitious code, and you'll see this is a common practice when you're downloading other shapefiles to use a specific marker for this is a missing, not available, as a putting in NA itself, like you might would in SAS or in our data set, so that you can delineate between those. Really great questions. Very particular shapefiles, geodatabases have very particular format. And the other thing is you can't have field headers that would be really searchable and easily retainable if they go beyond 10 characters as well. That's why we typically have shorthands, and is one of the reasons why we also have alphanumeric code systems that typically would be aligned if you work with the census data on different field headers as well. It's one of the limitations of working in GIS as well. Good question. Thanks, Zach, for the interruption. Okay. So again, I'm going to open up the properties by right-clicking on our tracks and coming down all the way to the bottom and clicking on properties. Okay. Before I go into symbology, I'm also going to just click on this information tab at the top. This is something where it'll help you to be able to identify if you're working within your geo package and you're working on a map. It'll tell you where everything is stored. So this particular one, it'll tell you the path overall. It'll also tell you the type of data, the coordinate reference system that it's been placed into as well, such as this was a North American datum 1983. So you know the reference system that it's being used. Currently, we only have a coordinate reference system and not a geographically based one right now. So this is how you can quickly look at information. And if there was something where if you moved a folder, this would get a little question mark next to it because it would no longer be connected. Not question mark, question mark or exclamation point. And then you could always reconnect the path by just clicking on this to where the file is itself. So if you ever run into a problem where it's disconnected or it's not showing up in the left-hand side, you can always do that. I'm going to now click on the symbology tab here in the panel. And this is where we can change colors. So for instance, if we wanted to change the color of the background. We could always make this be something else. So I can just click here and maybe choose a recent color I've done. Or if I want to look at other colors, I can always come down to where it says choose color and then use different ways of however you like to manipulate or work and select your color patterns as well. Wheel, wherever you like. And that's one way that you can change your data. Anything you want to change, you always have to hit OK. And then it doesn't immediately shift. As you can see over here, it's still the pink. I actually have to change it here by clicking apply or OK. And now it formally changes. Let's see here. Also, if you want to change other aspects, you can click on simple fill. And this is where you get the opportunity to get what is the outline, or they refer to as the stroke color here. So you have the fill and then you have the stroke color, which is the outline. That's where maybe I want to make this like a lighter gray or something like that to make it a little bit easier to see. Differentiate here. Right. And then I'll click apply. And then I can see on my map that I can get, instead of a black outline for every tract, get this. Now, let's say that we want to actually look at one of the variables as opposed to just a general topographic, just showing where you have general information on where the census tracts are located. In the top part here where it says single symbol, if you left click there, or you can go to the drop down right here and left click, you can get different options. If you are using a text-based field, you'd want to use categorized. Since we're using numeric and integers, we're going to want to use the graduated. So we're going to create graduated symbols of our data. Pause here in case I'm going a little bit too quick. And we're going to play around a lot in the symbology to make maps. In the value here, if I click this little drop-down box at the top for the value, you'll see it allows us to select anything that has a numeric-based field attached to it. And if I scroll down to the bottom, that's where we find our PM 2.5 over here. I'm going to left-click there, and it doesn't automatically load your data. You have to come down below it where it says classify here and left-click. And why is because you need to choose the mode. So what we're looking at is quantiles, which is based upon the distribution of the data itself broken up into 5 classes. If I want to reduce the classes and look at quartiles, I can by just clicking on the 4, and it will reduce. If I want to increase this to maybe look at septiles, I can always do that, or deciles if I like as well. And every time I change it, it's going to add more. I'm going to reduce this down to just 5 for quantiles. One clear thing is it will still say equal count quantile because that's what it defaults to, even if you increase this to 10 or you decrease it down to tertiles for 3. It's always going to change. When you're trying to select what you want to do, you always want to also, with the map breakpoints, look at your data as well. So I can click on the histogram and click load values to make sure that we have a data set that would approximate a normal distribution in some way to make sure it's appropriate to utilize that actual distribution pattern of those breaks themselves. So here we have something with the PM 2.5 distribution that does have some skewness, but overall does approximate this. There's also things that you probably would be doing potentially in other softwares ahead of time as well as you're playing around with your data. But just as a reminder, we always want to look at our breakpoints and choose which ones we want to use. So I'm going to click back from the histogram to the classes. And on the mode, I'm just going to select here so you can see you have the options of equal interval, fixed interval, logarithmic, natural breaks, pretty breaks, and standard deviation. I don't have time to go through all of them today, but equal counts is probably the one that I use the most. And if I have something where I want to specifically type in, I'll show you how you can do that in a moment. If I want to change the color scale here, it defaults to this nice red. If I click apply, you can see here we have this red distribution between whites, pinks, and reds. In the drop-down box here, I can choose other ones. I can say, okay, well, I want this to be blues. Or if it's not listed here, I can always say, I want to see all the existing loaded color ramps. So maybe I want to do something from red to blues. In this case, uh-oh, the red is at the lowest. Well, maybe I want to flip that. So I click on the drop-down box and I can say invert the color ramp here. For the purposes today, you can choose any one that you want. There's no real wrong choice right now. A lot of times, just in terms of generalities, with utilizing these symbologies and color ramps, sometimes there's a lot of value to being able to show across a single spectrum of color associations with different things like normalized difference vegetation index. A lot of times you'll see people showing it as green, even though in the actual ultrafine band it's not green, but we think of shrubs and trees and so on as being green, so showing them so that people have a way to interpret those results more naturally is a nice approach. Always you got to remember that a segment of the population is going to be colorblind, so using spectrum of colors like green through reds that cascade through oranges is potentially not going to be observable by a percent of the population as well. So you want to keep that in mind. Utilization of too many different colors also can be very distracting overall. The final piece that I usually provide as a recommendation when choosing different color patterns for different maps is if you believe that what you're looking at does not have an actual safe exposure value, then the utilization of things that would tend to be like blues versus reds, people will superimpose their interpretation on that to be safe versus non-safe, and you want to be cautious of that. So for my purposes today, I'm just going to keep it extra simple and just use a single color scale ramp just for the purposes of being able to look at this. I'm going to click apply, and then I'm going to go ahead and click OK. And what we have here is referred to as a layer. So we have shapefiles and geodatabases, which is the storage-based format. And when you're manipulating these on the left-hand side in the layers, that's what each one of these will be called as well. So it's going to default and change our legend, as you can see here on the left-hand side. You can also see that there's potentially some problematic areas, especially as you get into highly dense areas. It becomes overwhelmed, the color pattern, just on the outlines themselves. So a couple things we want to do. One, let's first rename this file so we know what this actually is. To rename the header on this, we can right-click and then come down to rename layer. And this is important for the stage also later on when we want to make a map of these different locations. Here, what I would do is I'd call this PM, or potentially since it's annual average, PM 2.5, and put the units in as well in a shorthand. Yeah. Now, before we do any of the next steps, one clear thing that we've not done yet is save this project. So to save, there's two ways you can do that. One is you can click on the little floppy here, or what you can do is come up to Project and click Save As. And then I'm going to go ahead and save this in my QGIS 101 folder. And I'm just going to call this my QGIS 101 training. A lot of times what I'll do though is I'll actually have a date stamp, especially if I'm going to be version controlling. So just good data format process would be, your project, or maybe initializing like the type of analysis you're going to be doing, and then providing that with a date stamp so that you know when this originated. Excellent. Now you can see at the top, it switched from untitled to our format here. Also, I'll show you down here, it's created a shortcut so that you can launch this in case you accidentally close the window by Xing out as well. Additionally, if you accidentally close one of these little layers, well, you can always come into this view and you can turn your panels back on or off with these things like browsers. So if I click this little layer, it'll turn it off. And then I can come back to this and say, I want my panel, and I want my layer panel back. So a lot of times when we're clicking around at first, we might accidentally click on something by mistake. Okay. So right now this map, this goes to spatial scale. Your analysis might be a nationwide analysis, for instance, at a neighborhood scale using census tract information. But to show that data in this format, especially with a vector format and not smoothing across it, will be problematic for people to be able to interpret overall. So sometimes maybe you want to take your data and aggregate it up so you can show that. And maybe you would be working with county level data, but you had annual averages provided to you at a local level. Well, what we can do is we can aggregate this data based upon a specific field. I'm just going to open our attribute table just to show you what field we're going to do. Here we go. So we have a county code here, the name of the county. We can use this field to be able to aggregate and reduce, or in GIS terms, dissolve the data set down while either taking sums, averages, or doing other calculations on other parameters in our data set. So for instance, we can go from census tract level PM 2.5 to be able to have county averaged PM 2.5 instead. So with that, what we need to do is run a processing toolbox. If you don't have this open, there's a tab at the top here called processing and toolbox here that you can turn on. So I turned it off. I'll click on processing and toolbox here is now on. Within this little search term here, I can type the word aggregate. Went a little too fast. So we have aggregate, and you can see tools that are recent, and it falls under our vector geometry. So I'm going to click on this aggregate tool. I double click on it to launch it, and it'll open up another window for me to use. It's defaulted to the shapefile that I currently have. If there were other ones here, I could always use the drop down and switch to which one I actually want to perform this processing on. The group expression, this is the field you want to aggregate on. So this is the one where in the drop down box, I'm going to choose the county because I want to get a county level aggregation. It's going to provide you with all the available fields right in the middle here. Some of these we want to keep, maybe like the state and the county itself, but the others we can remove. So by clicking on this 0 here on the left-hand side, I can highlight this field. I can then remove that by clicking on this delete selected field. So it won't calculate or perform a function on that. I can do the next 0 as well and delete that. I'm going to keep the state and the abbreviation, but I'm not going to want to concatenate them. So in the drop-down box for where it says state, I can click here and say, just give me the first value, because it's going to repeat over and over. For the abbreviation, I'm going to do the same thing for the estate abbreviation. And then the community, let me just move this to the side that you can see. Great. And for the county, I'm going to do the first as well. And what that's actually going to do is it's going to say, for the county, it's going to come to the first county name that's in the data set and just put that as the county header field. All of these other ones from 3, I'm going to scroll down, and if I hold like shift and click on 16, I can highlight them all and delete them in mass. So now I just have the PM 2.5 and TRI site, and on the 4, I'll highlight that and delete it as well. So what we're looking at here is we have the state abbreviation, county, and PM 2.5. I don't want the sum of the PM 2.5 though. So in the little drop down box on the calculation I want to perform, I'm going to tell it I want just the mean. But you could choose the median or something else if you like. So now what I'm going to do is I'm going to take our census tract data, which is at a smaller spatial resolution, and I'm going to aggregate them based upon the county ID and the name to be able to obtain a new file that's only going to have the state abbreviation, the county name, and then the annual average mean PM 2.5 for that county. Once I have this all set up this way, I can scroll down just a little bit further and see that what it's going to do is create a temporary layer for me after this, which will not be a permanent shapefile. I'm going to go ahead and click Run. It's actually performing this analysis on the filtered data. That's really important, right? Because what we're looking at here is that the information is going to be working. Oh, I had a failure. Interesting. My parameter piece, I think something wrong into. Oh, I had the concatenate here. I thought I had selected first value. My bad. Let's check the chat while we have a moment here. Okay. There we go, success. And it will pop up as this aggregated field over here. I'm gonna go ahead and close this. And that might be faster or slower depending upon your computer's processing. Our aggregated field, I'm gonna right click here and open up the attribute table for this data set. And what we can see is that it produced our information. So it reduced our data set census tracts down to the individual county level information that had within it these different exposures. And we have the PM 2.5 here for all. Let's say that we want to now see the annual average PM 2.5. What we can do is right click on the aggregated and come down to the properties and change the symbology, just like we did when we were doing this with the census tract. I'm going to change the single symbol in the drop-down box to graduated. And then the value, I'm going to change this to PM 2.5 and click classify. I'm going to go ahead and change the color ramp here to be the blue so it matches. And you can see comparing over here that it's reduced on sort of these values on the different breaks. So it's not a one-for-one match. If we wanted to, we would have to change these manually, and you can just do that by clicking in, and then you could type in if we wanted this to match exactly like 1.33 to 6.45 here. I'm going to leave it as it is for just right now, just because I want to be able to show you the differences. So by averaging up, now you can actually observe the county level at a nationwide scale. So you can easily take information at a lower resolution and be able to aggregate it up into a larger scale. In this case, I could also change the name here by right-clicking on the aggregated, it says that. And I could rename this to rename, also to say annual average PM 2.5 micrograms per meter cubed. Okay. Now this is a temporary file on its own here. Let's go through a process and step and create a permanent shapefile as well. A lot of times you'll get really large data sets. That's the way that they're provided in a public format to help cover as many groups as possible. A couple things. Yes.
Could you just quickly demonstrate again how to get the attribute table for a shapefile?
Sure. We right click on the header of the field and come to open attribute table located right here and left click. And then we'll open up the attribute table.
Thank you.
Yep. Thanks, Zach. Additionally, now that we have two layers, I should show you how we can view things. So if I wanted to see the layer below, I can just turn this one off and there's my census tracts. I can turn this one on here and here's my counties. If I wanted to swap the order, I can left click and then drag one below or above the other as well. So I can drag this up so my census tracts are now above. And if I click off, I can see the counties below. I also, as I create a lot of files, if I wanted to reduce them down, I could use these little ones. So what I'm going to do is I'm going to turn off this county level data set, and then I'm going to minimize it so we don't get it confused as well. Also, a lot of times when I'm playing around before I make a map, I will right click and rename things and maybe put at the front things like in parentheses, this is a county map. That way I know the differences between what I'm looking at versus this is a tract map. Because we're working with only a few, but a lot of times you'll have many, many layers that you're building and testing out, either the color patterns, the breakpoints, and then working with your groups to decide what is the best representation of the data overall. Let's go through a step where we subset, because let's say we want to go from nationwide data down to a specific location. I'm going to open up our tract level. We're not going to work with the county anymore, but coming back to the tract, I'm going to right click and go to Open Attribute Table. And we have state level information. So what I'm going to do is I'm going to reduce our data set down to a single state. You can work with any state that you like. I'm actually going to work, since I do so much work in Massachusetts and California and big states, I'm going to actually do an analysis today on Louisiana. So I'm going to right click here and open the attribute table again. Just for that, it's a little bit easier to see how we do this next selection and creation of a data set to subset with the attribute table open. So in here, let's say that we wanted to go about identifying locations. Well, a nice part of working with the GIS is on the attribute table itself, if I were to click on this little one here, it would actually highlight the area and select it. So you can see I have one selected out of all the census tracts. If I wanted to get more than one, I could always hold Shift and click. Oops, I hit caps lock. Shift. There we go. And get more. If I wanted to randomly select, I can click one and use Control to select around and create my own features. Any point in time I want to remove my selection, I have this deselect option here, where it's the little selection yellow with a circle with a hash run through it. I select that, and now I have everything deselected. I'm back to 0 selected items. So you could sort, right? Like let's say I wanted to identify. I could technically sort on the state variable itself. Maybe scroll until I find Louisiana. It's quite labor intensive and the potential to make mistakes is really high, as you can see. So I gotta scroll around. But I could technically do it this way if I want to select just Louisiana. I could say, okay, I'm gonna select here, and then I just want all the census tracts. So this could take quite a bit of time to do overall, as you can see. And it's really not feasible when you're working with large data sets like this. So instead, what we can do is I'll clear the selection, is right at the beginning of our selection options here. We have this E, which is a select using expressions. I'm going to left click there. And just like it created a function editor window for us in the aggregate tool, it's going to open another select by expression tool in this case. And what we're going to want to do is we're going to choose based upon a particular field and value. So we're going to, similar like a filter, we're going to instead do a selection. In this case, I'm going to hit the little drop down so I can see. So the little arrow next to where it says fields and values in the middle here, I just click there on the fields and values. And then I can see all the fields in my data set. And then I'm just going to select the state abbreviation and double click it, and it'll put it into our equation builder, our expression builder. Again, I can delete that, but and add it by just double clicking. So I double left click there, I get this. I can then use in my operator the equal sign, and then I'm going to select all unique value here on the right-hand side for groups. If you already knew what you were going to select, you could always type it into the expression builder. But in this case, I'm going to show you how we do this way. And I'm going to double click on the LA and put it here. Since it's text, you need to put it in single quote. If it was numeric, you could just type the number in. But text-based operators need to be provided with a single quote around them to be searchable. I then come down to the bottom right and click Select Features here. And what it's done, so you can see if I close this window, is it selected all the census tracts in Louisiana. And I can see them on the map here. Now that they've been selected, I can create a new shapefile just called Louisiana census tracts. I do that by right-clicking where it says Tract Annual Average, so that shapefile that we were working with, and I scroll down to where it says Export, Save Selected Features As. So what I did was I right-clicked on Tract and came down to Export, Save Selected Features As. It'll open up a new Save Vector Layer window. What I can do is in the field name, right next to it, you have the 3 periods here to open up the browse window. I can find my folder. If it's not automatically popping up, I can navigate to my QGIS folder. And what I'm going to do is I'm going to create a name and structure where I'm going to keep this same name, but I'm simply going to put in front of it LA for Louisiana. So I know it's the same data set that's contained within the folder, but now I've subsetted it down to this particular state. I can click Save. And since it says here, Save Only Selected Features, now when I go down to the bottom, I'm just going to pull this up a little so I can see where it is. Go. And I click OK. It's going to create this new shapefile for me. I'm going to go ahead and turn off my annual average PM 2.5 for the entire United States, and I can see just my Louisiana. If I want to zoom to this, I can't use the little magnifying glass here because that will put me at the full extent. I could use the zoom in button here and create a little square and try and drag around it, and then try to use the pan to get it exactly centered. But it's much easier to just zoom and have the software center the subsetted data for you. So if you ever want a particular layer to be completely centered, which is exactly what you want to do before you actually move to the map creation process, is you can right-click on the layer and then select Zoom to Layer. And it will maximize the extent and center it for you. Okay, so here we can create another PM 2.5 or temperature map. So now it will just be based upon the cut point or the distribution of the data just within Louisiana. So what I can do is right-click and then come down to Properties. And then in our Properties window, where it says Single Symbol, I click here and change it over to Graduated. And then in our little Value window, I can scroll down like we did before on the previous 2 maps to where it says PM 2.5. I can then classify to see our data. And then I'm going to take a look at the histogram and load the values. And again, now we have a distribution pattern that's only going to be representative of Louisiana. So we don't have the same range as what we saw across the United States, which is what we would expect. But still, it's approximating almost a normal distribution. So I'd feel comfortable with using, again, more of a class break that's based upon the distribution of the data, as opposed to trying to put something else in. So when I'm ready, I can click Apply here, and it will make a new one in red. I'm actually going to change this to be blues, just like it is for the others. Click OK. And we can see the PM 2.5 distribution across Louisiana. Now, let's say I want to make a couple different Louisiana census tract level exposure maps. I don't have to go in. I could go in and say add layer and go through that process again. Or what I can do is I can right-click here on the tracks for Louisiana and then scroll down to where it says duplicate the layer here. Excuse me for one moment. There's just a little bit of noise outside. Apologies, there was a mower outside. I just need to turn that off, so it's background. Coming back to this, what we're looking at is we want to duplicate our data. So we end up with this copy over here. I'm just going to go ahead and minimize this one on the left, but we can see the copy. What I can do is right click and come into the properties here. And now we have our PM 2.5. So the nice part is it's all loaded up for you. If you want to see potentially the PM 2.5 in a different distribution, I could always choose the mode here and choose equal interval. And what the equal interval is going to do is takes your min value and your maximum value and takes what is, you subtract them, it takes the difference, and then you divide it by the number of classes. And that's where you have equal amounts in your breaks themselves, but it no longer is representative of the distribution in your data. So here, if I load the values as well, we actually see that, there's just broken up into our equal amounts. If I click OK, so now we have a slightly different map. I'm going to turn this one on, and you can see if I choose and select them. So the first top one here is based upon quantiles, and then the one underneath it is based upon equal interval. And that's where you can have very different communication patterns with how you're going to work with your data. Right. I'm going to open up this tab again and come back into our properties window. And then this time, instead of looking at PM 2.5, let's say we want to look at heat or something else. Here, I can come down to our max temperature, which is the average maximum temperature across the summertime period for this year. And I'm just going to change the pattern here to be something like reds instead. And I can click OK. And now we can have layered on top of each other. We can see some of the different patterns. Sometimes it can take a moment for this to come through. I'll hit classify here. There we go. So I hit classify. That's the step I missed. So now we have the changeover to this. Okay. And there's our map for all. I can rename this by right-clicking this to say rename. And what I can do is I can call this one here LA, or we know it's Louisiana. I can call it average summer max temp. Celsius. Go. And then with this one, I could rename this to be annual average PM 2.5 per meter cubed. Great. And that's where we can have our air pollution and temperature layered maps. We could then do another subset just to practice. If I want to open up this attribute table for our Louisiana census tracts, we could reduce it down to just look at the area that contains New Orleans within the Orleans County. So what we can do again is write a new expression. And this time, I'll open up my fields and values. I can scroll down and double click in county, type in equal sign, click all unique, and find our Orleans. Double click that in, and we see county equal Orleans. I can select those features. And then see in our data set, it selected 184. I'll click OK and close this. If I wanted to see just the selected data that I've identified, in the bottom left of this attribute table, I can click Show All Features and switch that to say only Show Selected Features. And I can also see on my map where they're located. Again, I'm going to practice exporting this as a new shapefile to be subset. So I'll right-click on the annual average, come down to Export, Save Selected Features As. Here, to be able to save, what we do is click on the 3 periods to open the browser. And I'm going to select our LA for Louisiana. And I'm just going to put in front of this Orleans because it's the same data set that we were working with previously. Now it's been subset to Orleans in Louisiana. Click Save. I can see it's all set up. It's saving only selected features. So I'll click OK. And now we can see our smaller area. I'm going to, again, minimize and turn off these other maps that we've created, these layers, and I'm going to zoom into Orleans. Fantastic. Now let's say that we want to make a map showing the health distribution within one of these cities. And then maybe we'd follow that up by showing some of the distributions of the exposure at a hyperlocal level. Well, the first thing we can do is open up the attribute table and decide what variable we want to look at. As I said before, we're going to use the coronary heart disease estimated prevalence at the census tract level per 100,000. And that's represented in the shorthand here as the CHD. So I'll close the attribute window, and then I'll open the properties for our new shapefile here by right-clicking on it and coming down to properties. I'll change the single symbol here to a graduated. And then the field value that we're going to use will be CHD. Going to go ahead and classify, so we'll load in the data. I'm just going to take a look at the histogram, again, to look at our data. It looks like we have a lot of zeros as well. So it's something 0 to 1, we have some values. So it's slightly skewed. The zeros are something that we want to consider because these are estimated health information. So I'm going to go ahead and accept this for now and click OK and look at our data. Now, if we wanted to figure out like, okay, well, these are interesting pieces here. They're very large census tracts in urban areas, especially down here. Now, the size and area in urban environments for the shape of different census tracts is based upon population density, which tells me either no one lives in these or very, very few people. And that's why they're so large compared to the other census tracts that are contained within them. Now, just looking at this with a background that we currently see, we're not able to make any interpretation, but you can add in what's referred to as base maps. And particularly you can add in satellite-based ones from either like, Google, you can OpenStreetMap, or you can add in Bing base maps if you want to see things. We do that by coming up on the top tab here to where it says project. We scroll across to where it says plugins. And this is the interesting part about this being open source, is that people create different openly available software packages that can lie on top of the QGIS software and be able to interact with it. So we can manage and install plugins. It's going to open up a window. And then this will allow you to add different plugins. The specific one that you want to add if you're looking to bring in a base map, that would be an image-based one, is referred to as the quick map services. So I'm going to type in quick map, and as I keep typing out, you can see it's all one word, quick M. And if I were to do AP, we find the map services. This should be turned off on yours if it's the very first time you've ever used it. And all you have to do is just turn it on and click down here to install or update. And it can take a minute or two for that to occur. So I will pause for a second. For anyone that is following along, would like to finish that process. Once it's ready, if you continue on from the plugins to this web dropdown, it'll be added as a function and tool within your quick map services here. And this is where you could add in OpenStreetMap layer if you wanted. So I'll click on OpenStreetMap standard, and I can see what's behind this and see, oh, okay. Well, it looks like this tract is almost entirely water. This one is really made up of like potentially greenland and other areas, but maybe there's still some information. So maybe I want to convey and look to see, okay, in these three, is there anybody that lives here? I can do that by coming over here and choosing this select by features out of my ribbon at the top. So I can left click on select features, click here, and I can hold shift and click the other one and the third one. Now, when I open up my attribute table for the Orleans area, I can see I have 3 selected. And in the bottom left, I can switch from show all features to show selected. This allows me to then scroll across and see, okay, in 2 of these, there's no one that lives there. But in the other one, there is an estimated total population of 2,000 people. We wouldn't want to lose that. So I'm going to clear this selection here and close the attribute table. That means we could probably create another filter. So I'm going to right click on this filter, this shapefile, and add in a new filter. Here, what I can do is I'm going to type in a new filter for E total pop. So we're only going to want to select places that have a total population that is in excess of 0 people. So I'm going to say we want to have everyone else that is greater than, oh, I'm sorry. We're going to want to remove, filter out everything that is equal to 0. So if I click that and I do a test, uh-oh, I went the wrong way. There's only 3 rows. So in this case, I would want to say, oh, okay, I want everything that is greater than 0. I can run the test and see, oh, okay, great. Now I've got the areas that I'm interested in. So it's a nice feature where you can use the test button in case you're not sure about which ones you're actually going to be filtering or selecting out when you're just learning to practice and process this information. So on the next thing we're going to do is click OK. And now what we have is a nice little background. It's got some of the road information that we might want to use. We're almost ready to transition to creation of a map. Maybe you want to use the OpenStreetMap as a nice background. Maybe we want to use something else. If I don't want to use this OpenStreetMap, I can always come up to the web here and come down to Web Map Services. I could choose something from NASA, or what I could do is choose the search QMS as well. And what that's going to do is open up a new browser on the right-hand side. And I can increase this just by clicking here, just at the top, and pulling it up a little. And this might be blank for you, but what you can do it under search here, in the search string, you can just type in the word Google, and it'll start to search. And what you're actually doing is going against their servers to actually find existing imagery that you can pull and stream. So here we go. Okay, we have the Google. We have a whole bunch of different options because it's searching for different data sets. We're actually going to be wanting to find the Google satellite, I believe. So type in sat. So get the GLAD, Landsat, and mosaics. So the nice part is you can get all set. And then I scroll down just a little and I can find the different Google satellite ones I might want to use as a background here. So the nice part is it'll pull all sorts of different imagery for you to work with live right through the data. If I want to add this, I can just click add here and it'll add as a layer here. So I can turn off my OpenStreetMap and now I can have a nice little background that is the satellite-based imagery in QGIS. We've been working a lot. So before we transition to mapping, I'm going to click Save Project here. And then what I'm also going to do is I'm going to right click and rename this file. So we have our final layer. So we're just about ready to make the map. Typically, you want to get all of these things ready before you transition to the actual map layout part. And that way you don't have to come back and manipulate any data. So to begin with, what we're going to do is we're going to work here and change this by renaming this to the CHD prevalence per 100,000. Great. So now we want to go and make a map. We can change our maps by coming up to the project up here in the tab at the top, come down to New Print Layout. It's going to ask you to create a name, and we're going to call this CHD Orleans, LA. And it'll open up a separate window for you to begin to manipulate and process. And I'm only going to go over some of the basic functions of map making here, but you can easily Google or you can go to YouTube and also find how do you make different maps in QGIS. What I'm going to do is first add a map frame. So since these are connected, the actual QGIS project and the map layout, we can click on Add Map here. And you want to left click and drag to create a box. And I'm going to go for the full extent right now of the map. Sometimes people will leave it halfway and put a legend underneath. There's all sorts of different formats. For today, I'm just going to create a full map. Since we have a lot of information because of the image behind it, it might take a moment for it to render on your computer. But here we can see our map. And this is the equivalent of what would be a landscape layout for a full individual page itself with the printing. The way that we interact with things are with the tools on the left-hand side, and then in the top piece here with the different tabs and ribbons. The first thing we want to do is add in essential map and elements. We need a north arrow, we need a scale bar, and we need the legend itself. So I can click on Add Item here, and come down to Add North Arrow. I want this to be pretty small, so I'm just going to draw a small box by left clicking and doing here. And then I want this to be out of my way, so I just click on it and drag it down to maybe the bottom right over here. If you wanted to select a different type of arrow, on the right-hand side is how you interact with the item properties that are contained within your map layout. So there's different arrows underneath this app symbol. If this is not open, you can click this, and then you can find arrows, and you could choose a different arrow layout if you wanted to swap it. For next item, I'm going to come up to Add Item and add a scale bar. And I click and drag to create a new scale bar. I'm just going to move this down by left clicking and dragging it over. Again, the item properties on the right-hand side are located here, so you can see things. If I want to interact with them, what you can see is the units are laid out this way. It's kilometers. If I want to change this to something else, miles, meters, you could always choose those. I'll keep it as kilometers. You can also force it to do different multipliers. Also the label units you can change. There's a little bar here for you to scroll down. If I scroll down a little bit, this is where you can change the number of segments if you want, left or right, the width of those. So I can keep going down. And I can also see some of the other pieces like display. If I expand this out a little bit, I can see what the different color patterns are as well. And if I, underneath the display, I come down at the bottom, I can see this font. And you can see with an image-based background, it's really tough to read. So if I just click on the word font here, it'll change that box. And this is where I could say, okay, well, I actually want to change this color to maybe be white instead. And now those numbers are a little bit easier to see. I can also change the font type. I could change this by clicking on the drop down and type in A for Arial and find Arial here. The resolution when you're creating the map, do not be worried. It's going to look not that great. But when you go to the next step of actually creating an image from this in its final format, you can tell it what DPI you actually want it to be, what image ratio you're looking for overall. To go back, I just click this little arrow at the top next to the scale bar font, and it'll bring me back to the sort of first window to interact with the different scale bar elements. The final item we need to add to the map is the Add Item here in the tab and come down to Add Legend. Here again, I'm going to left click and drag to create a small box and let go. And what it's going to do, it's going to automatically update and add in every legend that we've built so far in our map over here. Turn that off and then here. Great. So what we can do first is in our legend, we only really want to have the map be right now for coronary heart disease prevalence. So I'm going to scroll down just a little bit to where I see legend items. And if this isn't open, go ahead and click on it. And then I have to turn off auto update. That now allows me to interact. You see these things become available to be able to manipulate my legend once it's available. If I wanted to switch the order, I could always select one of these and push it to the top or push it up. If I only want to keep the coronary heart disease, what I can do is select one and then use a little delete minus button in red here, and it will remove it from the legend. And if I want to remove multiples, I can always use either Control or Shift to select and remove them. So now we just have the individual legend item that's in the map itself. If I keep scrolling down in the item properties on the right-hand side box, I can find the fonts and text formatted. I'm going to expand this box and I can see, oh, well, I have the option of manipulating the font for the different items. Overall, the name of the CHD prevalence is related to the subgroup, and then the individual items are related to the item font. I'm going to first change my subgroup font here by left clicking. And then in the drop-down box, I can choose Arial. And I'm going to change the style to maybe be bold. I can increase the size if I want, maybe up to like 15. And then I'll go back in the text format here. In the item, I can click here, also change this to be Arial. I'll keep it regular. Maybe I'll increase it to 13. Again, the resolution doesn't look great, but now what you have are all the required elements. If you wanted to play around with like the background, if you didn't want to have one, you could always turn this off here, or you can turn it on. You can also turn your frame color on if you like as well, but that's something we're not going to use because we have an image in the background. If we didn't have our image on, then we could make the background a certain color if we'd like to as well. Now that we have our map, what I'm going to do is save this layout again by clicking save here, little button. And then I'm going to come up to the tab, the tab that says layout, and scroll down to where it says export as image. It's just going to give me this warning that it could take a little bit because I'm utilizing one of these live data sets from Google. But I'm going to just save this in my QGIS folder as CHW Orleans LA map. Maybe I'll give it a map 1 and a date to go along with it. You can change the type if you didn't want a TIFF, if you want a PNG or JPEG or something else. I'm going to keep it just as a TIFF. Click Save, and then it'll ask you what resolution. So typically I work at just 300, but a lot of times journals will want now like a 750 or a 900 DPI. So just keep that in mind. It will take more time for it to generate and render. And then I'm just going to click Save. Once it's done processing, I'm going to open up my folder and I can see my TIFF file here. And if I double click on it, here's my map. And you can see the resolution is much, much better. I got to control the DPI, so it's very much improved. You can now take this and bring it into a Word document, a PowerPoint, whatever you like, and be able to show this information. So at this point, what I'm going to do is I'm going to stop the hands-on piece. We've gone through all the training elements that we were talking about doing on the hands-on. How do you add data, begin to navigate the QGIS software, open attribute table? How do you do a little bit of manipulating of the data itself, either through an aggregation or also subsetting of data? And then gone through the process of how do you create a layout, add the maps themselves, consideration of different breakpoints, and then create a map with a nice background to accompany it as well, while filtering out areas that you might not want to include in the map. So at this point, I'm just going to come back to just go through a couple final slides, and then we'll open it up for Q&A. Here we go. So There's a variety of different examples that we can give you and links, and we'll post these if you'd like to learn more about various ways that people create maps, especially through online mapping environments as well, such as ArcGIS, Flourish, and so on. So creation of these maps in different environments. We also want to thank you for joining us as well. And we do have more webinars that are being planned. Dr. Rachel Nethery will be doing a presentation and a session on working with meteorological data for climate and health. So if you're interested in our series, please stay tuned. There's going to be more. And as always, we're recording this information and you can find it on our CAFÉ website. If you haven't yet joined our community of practice and would like to participate, you can use our QR code here or go to our CAFÉ website page and join there as well. Also, you can follow on Instagram, or also a benefit of joining the CAFÉ is we have a live Slack channel. We also have upcoming data discussions, networking events, also mentoring programs that are being established as well, and more webinars and trainings and workshops and code that we're going to be providing out to people. I just want to thank you again for participating. And if there's more questions, we can turn it over to the Q&A at this point. And I'm happy to go through either questions related to the software or you might have on working with maps. Thanks.
Thank you, Kevin. I think we had one question come in that might be good for the Q&A. Someone had asked how to add an attribute table to a shapefile. So rather than finding it on an existing shapefile, how it would be created.
Yeah, great point. So a lot of times you'll have a data set and it might have district or a zip code or a county or a state as an ID in the field. And then you'll have a shapefile that exists somewhere else. You'll actually conduct what is referred to as a join of the data on those fields. That's actually something that have sort of as like the next session ideas if you're interested in that, but also we can post some preliminary ones if they're related to that. But that's how you would do a join. And let me go and share my screen and go back into the software real quick. Okay. Come over into here. Let me turn off our QMS. And in here, if I type in join under our toolbox, you'll see this join attributes by field. This is actually the tool that you would use. And if you had another, let's say a data set that's on the county level, and maybe it was county-based mortality, you could join it to each county or each tract, depending upon which shapefile you chose, by just aligning two different fields based upon county, and then doing a merge, just like you would in another software. Any other questions, Zach?
Nothing so far in the chat.
Okay, well, if there's no other questions, I don't have to hold everyone here. Thank you again. If you do have ideas for other potential workshops and you want to join the community of practice, you can always suggest some of these items to us. I'm definitely, we're going to be having more GIS training. Some of them might be live sessions like this. Others will be current and being posted to our GitHub as well. So please keep an eye out if you've joined the community of practice, and also the newsletter that would be there will be featuring some of these additions as well. Elaine or Zach, anything else you want to add in relation to just bigger, broader pictures on CAFÉ?
No, that's it for me. Thank you, everybody, so much for joining us. This was a very successful training, and we look forward to having more data-focused trainings going forward in the future. So keep an eye out for registrations throughout the summer for other webinars that we will be hosting. And of course, let us know if you have any ideas or needs that we can help fill in this community of climate change and health.
All right. Thanks, everyone. Have a great day.